Okay, howdy. Just pull this up here. All right, so we're moving on from the primitive built-in types, and we're going to begin our discussion on variables in C++. This is going to take us through kind of a walkthrough of all the various attributes that variables have, some that are, quite obvious, others that, kind of lurk behind the scenes and occasionally come up at various times, but it is, important to start thinking about them now, especially when we get into, some of the other topics in this course. So variables. A program variable is simply going to be an abstraction of a computer memory cell or collection of program memory cells. The latter kind of part of that definition is meant to address, things such as arrays, which we haven't covered in much detail just yet, but we'll get to it, don't worry. Programmers often think of, variables as names for memory locations. And, after that, we don't think too much else about it. It's probably in the back of our mind, but we're, more interested in interacting with it than, thinking about some of the other attributes that are there that actually characterize it. These include the actual name, which we just mentioned, the actual address of the object to which that name's bound. It has one. In some, scenarios, that's very relevant. In others, we aren't as concerned about the address. Value, that's going to be huge because that's, that's what we're pretty much working with. And the whole point of probably declaring, a variable within our application is to store some sort of value. Otherwise, we wouldn't have constructed one. Type, again, that's going to dictate the, range of values that we can store, as well as the set of operations that can be applied to a variable of that specific type. Then we'll get into, new ones, scope, which is going to be a fun discussion. And then we'll also talk about the lifetime of a variable. But let's go ahead and just get into names first. We're going to talk about names in general, what's a valid name in C++, and then I'll get into some guidance or expectations that we expect you to utilize when naming your variables in your applications and really anything that you're submitting to this course for a grade. So first and foremost, a variable's name is going to be composed of a sequence of letters and digits. The first character of a variable name must be a letter, so you can't start it with a digit. Uppercase and lowercase letters are going to be distinct. In other words, C++ is case sensitive. So, hello is different from hello. Underscore is going to be considered a letter for the purposes of naming. However, names that start with an underscore are typically reserved for language facilities and the implementation. So it's not advised to begin a variable with an underscore. Although it's totally okay to have underscores within that variable name. So maybe a local variable. That's okay, because it's less likely to clash. While C++ does not impose a limit on the number of characters in an identifier, some parts of the implementation not under control of the compiler sometimes do. For all intents and purposes, don't, use a reasonable length of name that describes what it is, this variable is storing. Don't, you don't need to make it 100 characters long, by any means. And if something needs that level of description, go ahead and write a comment that communicates what's this variable is being used for. Some implementations are more restrictive in characters accepted in an identifier. For kind of a list of this, I'd refer you to one of the C++ resources available on the web. But for all our purposes here, this isn't something that we should necessarily be worried about if we're using characters from the English language with some underscores dispersed throughout it. C++ keywords cannot be used in our names. This would create a clash with those entities. So that's names. Now, naming your variable. So make sure your names that you're using in your program, and this isn't just restricted to a variable, but also things like functions, etc., which we'll get to. But here we're just talking about objects. So the descriptiveness of a name should be proportional to the scope of visibility. So if you have something that's being used throughout the scope of a function, it would be good to have a more descriptive name than something that is used in a very limited small block that's maybe a couple lines long. Do not use abbreviations when you're naming variables that those outside your project would not know or understand. Specifically here, make sure you're descriptive enough that the course assistants, teaching assistants, instructors could look at your code and have a pretty good idea what a variable's being used for. So don't use abbreviations that we might not know. And then follow the course naming conventions. We use the Google C++ style guide, which hopefully you'll become quite familiar with over the course of the semester. So our expectations is that names of variables are always going to be lowercase. Local variables are always going to be lowercase with underscores between words. So something like a local variable is a great example of kind of the format of how these should be composed. If there would be spaces in your variables, use an underscore to communicate that. When we get into functions, we expect your function parameter names to follow suit. When we get into classes, and we're not there yet, it's more or less going to be the similar composition, except there will be a trailing underscore there. But don't worry, we'll remind you once we've introduced classes in a couple weeks here. So now we're moving on to the next attribute that we're looking to discuss here, and that's going to be the address. Where does this object that we're interacting with actually live? When we introduce references and pointers, we'll essentially introduce you to the address of operator, where you'll be able to essentially ask a variable, hey, what's your address? And it will tell you where the object that it's bound to lives. So the address of a variable is the machine memory address with which it is associated. It will become possible when we introduce things like references to have multiple names associated with the same address. When more than one name can be used to access the same memory location, we're going to go ahead and call these names aliases or references. For instance, if total and sum are aliases, they're bound to the same object. Any changes to the value of total also changes the value of sum and vice versa because they're names for the same object. It's like Michael and Mike. So there is kind of a possibility to have two names that refer to the same person. Addresses are sometimes called a variable's L value. We'll get into this a bit more, but this is because it's what's required when the name of a variable appears on the left side of an assignment. So if you have something like int I is equal to 7, we have to know where I is in order to put 7 into it. So that's why we're going to call it an L value in this scenario, the address. Type. We've already talked a little bit about type. We'll go ahead and just emphasize what we said earlier here. The type of a variable, again, determines the range of values that it can store, as well as the set of operations that are defined for the values of that type. We've also briefly alluded to what a value is. The value of a variable is the contents of the memory cell or cells, if we're talking about an array, associated with that variable. Sometimes this is called a variable's R value because it is what's required when the name of the variable appears in the right side of an assignment statement. So if you have something like int I is equal to 7, in order to put the value stored in I into II, we have to know the actual value. So in this case, that's what's important here. So it's not just going out, it's actually going out and getting something. So lifetime. This kind of idea of binding between some sort of attribute and entity is really kind of a reoccurring theme. What we're concerned with here is the binding between, say, a variable and its type or value, or in some cases between an operation and symbol, which we'll present a bit later in the course. The memory cell to which a variable is bound is taken from some sort of available pool of memory. When we get into the stack versus free store, you'll really understand how this process is governed for those two different regions of memory. But for right now, just assume there's this allocation process, then there's a deallocation process. For named objects, this is always going to be associated with the stack. So what we're going to refer to as the lifetime of a variable, so a named object, is going to be the time during which the variable is bound to a specific memory location. Now moving on to scope. So a scope is going to have to do with where a name actually has meaning. In C++, what we'll see here is most scopes are going to be delimited by curly braces. So you could think that's a scope. Here's a scope within a scope, etc. What we're going to see here is that the same name can refer to different entities in different scopes. So you could have something like int I is equal to 7. Then within this scope, int I is equal to 8. We'll get into that a bit more here in a second. But one of the key takeaways is that the names are going to be visible from the point where they are declared until the end of the scope in which their declaration appears. So here, this I is going to be only visible within this inner scope here. The outside I is essentially going to be visible from here all the way down to here, with the exception of in here. And the reason for that is going to be that this internal I is going to hide the external I. And I have a bit more of a concrete example for that in a forthcoming slide. But if you had something like int I is equal to 7, you would totally be able to access I here because nothing hides it. So where I would be visible would be, again, from its point of declaration down to the end of the scope in which it's defined. So a variable is local in a program unit or block if it is declared there. So to these blocks, we have I's that are local to it. A variable that is non-local in a program or unit of block is essentially visible within the region of program. So if we had something like a global variable, that would be kind of visible throughout the whole execution of our program, unless, again, there was some internal scope that hid its value. So scope. Once we provide a name to an object, that name is restricted to the part of the program in which it's declared. So this is just perhaps an easier snippet of code to read than what I hand wrote on the previous page. Here, we have a global variable. We should probably minimize our usage of these in our application when we can. But when we do introduce them to a program, we're always going to provide a comment describing what the global variable is, what it is used for, and why it had to be placed in the global kind of namespace, if you will. The naming convention for global variables is going to be different from that of local variables. If it's going to be a constant, as shown here, it will start with a K to denote that, and then you're essentially going to have a snake case for the rest. So it would be something like like global variable. And again, the K is small. Now looking into our variables that here are going to be local to main. If we look at B is going to be restricted within the scope of main from its point of declaration forward. So B would be accessible here. It would also be accessible in this inner scope. And then it would be all the way down till before we return from this function. C is only going to be accessible from its point of declaration to where this block terminates. So right down to that, to the end of the inner scope. Now, you are able to have variables with the same name as long as they're in different scopes. And it's totally okay to do this if I mean, it's probably not a fantastic idea if you're using things like I and it gets very unclear, like, which it can get confusing if you're not careful with how you do it. But one thing that the compiler will not allow you to do is going to be having a variable name declared twice in the same scope. So notice here, I declare an integer object identified by A, and then I attempt to bind A to another object through another declaration. Essentially what's going to happen is that you won't be able to get an executable. The compiler is going to complain and essentially say that, hey, A's already been introduced. It's bound to this object. You can't also have it bound to another object at the same time. So when a variable with the same name exists in nested variables, and this goes back to about 3 slides ago, the variable in the inner scope is going to hide that variable in the outer scope. So looking at this code, A is going to be visible down to this point here. So if we look at this A, it will be assigned the value of 3 in the nested scope. Totally, that will happen. However, the next line after that assignment, we see the declaration of a variable named A, same name, in an inner scope. So that will now hide the A that was declared in the outer scope. So in this case, when we make the assignment of A is equal to 8, after the point of this declaration, that 8 is going in that variable there, and this variable is going to live down to the end of its scope. Now, once it goes out of scope, that A that we had will come back in. So when we attempt to assign A the value of 7 at this point here, excuse me. So slight error, let me back up. I'm missing my curly braces. So this A here is going to be all the way through here. It's totally visible in the nested scope here. So making that assignment will be there. The A in the outer scope is not going to be visible when that other A is, I guess you could call it in scope. However, once we return from it, it picks up again. So that A is going to refer to the one that we had declared directly beneath the main function's name. And then once we return, it'll go out of scope too. So on scoping your variables, C++ allows you to declare variables anywhere in a function. However, you should always declare a variable in a as local scope as possible and as closest to its first use as practicable. You should prefer initialization to declaration followed by an assignment. So if you look at what's shown in red is what you shouldn't do. If you look here, all these variables are kind of declared up front. We have 3 integers, variables A, B, and C. Their use is scattered throughout the remainder of main in various scopes. We can see here that A is used, it looks like, within the inner scope. Let me highlight this. A is used there, and it's also used here. If we go ahead and look at B, well, it looks like B is only used within this inner scope within main. And then if we look at, also it's used to actually assign to A. So A has one more thing here. And then if we look at C, well, C's only use is way down here at the end. So kind of looking at all that, there has to be a better way to organize this because, A's taking on a value in a inner scope where it could have been assigned before we even got there in this case. And then it's being used once we come back to the outer scope. If we look at B, B's not being used outside that inner scope at all. So maybe it makes more sense to just declare it and confine its use within the inner scope. And then likewise, C's not used to the very end of this. So, perhaps it's a good idea to not introduce that name until we're ready to use it. So this is how you can clean this up. We're going to go ahead and say, hey, we're using A right off the bat. I mean, if we were getting this value in the inner scope, it would be a bit different how we'd go about this process. But, based off of going from the red to the green, this seems like one plausible way of writing this. Then we get into the inner scope. And remember, B was only used there. So let's just go ahead and introduce B within that scope. And then its name is only restricted from its point of declaration down to the bottom. So it's a lot easier for accounting purposes. We don't have, a bunch of variables scattered throughout the main, which are only being used in very like specific places. We see here that, A is totally visible within that inner scope. It again is visible throughout the whole scope that it was defined in, including any nested scopes, unless its name was hidden, which is not the case here. And then we can see that we introduced C right at the end. In other words, we preferred to, initialize it as close to its first use as possible. I mean, it didn't make sense to do it in the red version up front when we didn't have a value to it. I mean, if this was a longer block of code, we might have declared it, right under the function signature. And then, if we don't use it to the last line, it's not clear what C is with respect to its type. And you'd start having a lot of kind of scrolling up and down. It's a lot easier to just introduce as you're at, as close to the first possible use as possible, and actually just initialize that variable with its starting value opposed to leaving it undefined. It's easier. You can read through, like, on the right side, it's okay, we have a new integer object C, it's getting assigned A, and we're doing something with it. In the red, it's kind of like, well, what was C? Was it used elsewhere? Is this its first use? And it could get really bad if you did something like this and maybe assigned A the value of C within, this scope, because at this point, we never gave C a starting value. So it's undefined. So the results of those operations would also be undefined.